Welcome to the Module 11 Part 3 notes. In this section we're going to look at how to calculate probability using the normal distribution. The normal distribution is the most common distribution in statistics, and it is our bell-shaped curve. So we're going to start with a reminder from Unit 1, our z-score equations. So remember, a z-score tells you how many standard deviations away from the mean a data value is, and it's calculated z equals the data value minus the mean divided by the standard deviation. So we're going to use the z-score equation to figure out how many standard deviations away from the mean a data value is, and then from there that's going to help us figure out the probability of being less than or greater than that value. So the first thing we're going to look at is how to find area under a standard normal curve. There are 4 steps that you must follow every single time you are asked to find a probability using the normal curve. The first thing you need to do is calculate the z-score unless it's already given to you. The second thing is to draw the normal curve and label where the z-score falls on that curve. Step 3, shade the appropriate region on the curve, so either less than the given z-score, greater than the z-score, or in between 2 z-scores depending on the wording of the problem. And then finally, use technology to calculate the area. I'm going to go over what it is you're going to use your calculator to calculate those with, and then there'll be a calculator video that actually goes through how to do those steps in your calculator. So let's go ahead and start with an example. It says example 2, it's really example 1. It also starts on B. So the first one says we want to find the probability that z is less than negative 2.4. So this is an example where I've already given you a z-score. I've given you that I want you to find the probability of being less than 2.4. So the first thing we want to do is draw our normal curve. So that's our bell-shaped curve. Okay, and remember underneath this bell shape is a histogram. And then the z-score for the mean, which is in the middle, is 0. So you can label that as well if you'd like. And then I'm going to go ahead and label my negative 2.4. Oops, that's a type. Oopsies. I was trying to fix something else. This should say less than negative 2.4. Nope, and now that's stuck as purple. That's fine. Alright, so z less than negative 2.4. So if it's negative, that means it's to the left of the mean. So I'm just going to kind of eyeball it, right? So from our empirical rule, we had 1 standard deviation out, 2 standard deviations out. So we're a little bit further than 2, so maybe right there. It's not an exact science on where to label these, just so long as you're getting it approximately correct. So that's step 2, draw the normal curve and label the z-score. And now we want to shade the appropriate region. So because this is a less than question, I'm going to shade everything less than my 2.4. So everything to the left of the 2.4. And that is the probability or the area of this curve that I'm going to try and find. So to find that area, find the probability of being less than negative 2.4. I'm going to put that negative in there. I'm going to now go to my calculator. We're going to use a function called normal CDF. Okay, and I'm going to put in the lower boundary. So where do I want to start calculating probability? So this curve goes out even further than what you can see, all the way to a negative infinity. So I'm going to tell it to start calculating at negative 1 million. 1, 2, 3, 4, 5, 6. Okay, so that's just saying I want the calculator to start calculating probability at 1 million standard deviations below the mean. Basically, I'm just trying to get out really, really far. Okay, and then I want it to stop calculating probability at my z-score, negative 2.4. And then finally, I'm going to tell it what the mean and the standard deviation are. With a z-score, your mean is always 0, and your standard deviation is always 1. So this is what we're going to put in our calculator to get the probability of being less than 2.4 standard deviations below the mean. And the answer to that is 0.0082. So there's less than a 1% probability of being further away from the mean than 2.4 standard deviations below. Okay, so that's the basis on how you cover a less than problem. If it's a less than problem, you are always going to have the lower bound as negative 1 million and the upper bound as whatever the z-score is, whether it's a z-score that was given to you or a z-score that you found in the problem. But if it is a less than question, lower bound is negative 1 million, upper bound is your z-score. So let's go ahead and look at another problem. This is a greater than problem now. So I want to know the probability that a z is greater than positive 2.2. So again, we've already started with a z-score, so I don't need to do that step. But let's go ahead and do our curve. Okay, when I'm going through and grading these problems in your discussion boards or your classworks or your exam, whatever it is that you're working on for this, if you do not draw your curve, that is an automatic deduction of 1 point for that problem. So if on the exam this question was worth 2 points, one of those points is drawing, labeling, and shading your curve. The other point is actually using your calculator to come up with the correct answer. Okay, so I have to see these curves on every single problem. Okay, which is why I said that this normal curve, this bell-shaped curve, was going to become your BFF. So we've drawn our curve. I'm going to keep labeling the mean just because that's a good kind of like eyeball point on where to put our z-score after that. So your mean's always in the middle, and it has a z-score of 0. So now we have a z-score of positive 2.2. So I'm going to go 2.2 standard deviations above the mean. Again, it's an eyeball. It's not exact. Okay, so 2.2 is right here. And we want everything greater than that, so I'm going to shade greater than. I'm going to shade everything to the right. So that's my drawn and shaded curve. So that's what I'm looking for, what I just shaded. So now in our calculator, we're going to use normal CDF again. We're always going to be using normal CDF with the normal curve. And now I want it to start calculating probability at 2.2. So it starts from left to right. So we're going to start at 2.2 and we want it to end at infinity. So now I'm going to put in 1 million. Again, it's just a really big number. And then our mean is 0 and our standard deviation is 1. We'll always use 0 and 1 for those last two values. So when we plug this in, which again I'll show you guys how to do in the calculator video, you get 0.0139. So about a 1.39% chance of having a z-score bigger than 2.2. Not great, but kind of possible. Okay, so now this was a greater than question. So whenever you have a greater than question, you're going to start by putting your z-score in the lower bound or the first value, and the second value or the upper bound is going to be positive 1 million. So the last type of problem we could see is an in-between question. So here I'm saying I want the probability that a z is between negative 1.27 and positive 1.95. So first step is to draw our curve. Doesn't have to be straight because clearly that wasn't straight because I ran out of room. Okay, 0 goes in the middle. So now I'm going to end up labeling two z-scores, and I'm going to do these in a different color. So first I'm going to label negative 1.27. Again, just kind of eyeballing it. And positive 1.95. And then I want the probability of everything that's in between those two values. So I'm going to shade everything in between. And that is what I'm looking for. So from our calculator using our normal CDF, now we want it to start calculating at negative 1.27 and we want it to stop at 1.95. Mean is 0, standard deviation is 1, and our answer is 0.8724. There's about an 87% chance that you are between negative 1.27 standard deviations below the mean and 1.9 standard deviations above the mean. Okay, so these are the three basic probabilities that we're going to be calculating. We're either going to be looking at a less than problem, a greater than problem, or an in-between problem. So all you have to know is, okay, what is the question asking? And then what did it look like when we had that type of a question? Did I shade to the left or to the right? Where did I put the million, and was it positive or negative? Okay. A between question, you're going to shade in between, and then you're going to put the lower z-score, comma, the higher z-score. Okay, so this was a basic example without any actual calculation of the z-score. So we kind of skipped over step 1 for all of these, just to get an idea on how to calculate these values. So what we're going to look at now is an application looking at IQ scores. IQ scores are normally distributed, that is a fact. They have a mean of 100 and a standard deviation of 15. So we're going to find the probability of having an IQ below 120. So now I'm not being given a z-score, I'm being given an x value. I'm being given an IQ score. Okay, so this is my x value. So the first thing I need to do, and I'm going to start numbering the steps, the first thing I need to do is calculate my z-score. So z equals 120 minus 100 divided by 15. Remember, you can do this all in one step if you put that top piece in parentheses. So when we do this, we get 1.3333. So now step 2 is to draw my curve. And I'm going to do step 3 right now too, which is to shade the curve. So I'm going to draw, label, and shade the curve. So my curve is bell-shaped. My mean in the middle is 0. And we have 1.3333. So maybe like right there, maybe a little further out. And then we want everything below that z-score because the question originally said below 120, and 1.3333 is the z-score for 120. So I'm going to shade everything less than or everything to the left of my z-score. So that's steps 2 and 3. And then the final step is to use technology. So we're going to do the normal CDF, which I'm going to shorthand to NCDF. I'm going to put in negative 1 million because it's a less than problem. One more zero. I'm going to put in the z-score that I found, 1.3333. The mean for a z-score is 0 and the standard deviation is 1. Those last two values are not going to change because we're finding a z-score. We are always going to find a z-score. So when we do this, we get 0.9088. So the probability that a person has an IQ score below 120 is about 91%. So most people have an IQ score below 120. All right, probability of finding an IQ above 90. So we're going to repeat these same 4 steps. So I'm going to try and keep the same color pattern going. So step 1 is to do the z-score. So z equals 90 minus 100 divided by 15, which is negative 0.6667. So that's the number of z-scores that a IQ of 90 is below the mean, so less than 1 standard deviation below the mean. Step 2 is our curve, and step 3 is to shade. I tend to combine those. So we're going to draw the curve, label 0 to give us a starting point, and then we want to go 2/3 of a standard deviation below the mean. So I'm going to go about here, label that guy, and then shade appropriately. So we want the IQ above 190. So now I'm interested in everything greater than this. And then finally, last step, using technology. Oop, that's not step 3, that's step 4. Using the normal CDF. So now, because this is a greater than problem, we're going to put our z-score in first, followed by a comma and 1 million, followed by 0 and 1. And now that we've done all that, we get an answer of 0.7475. So the probability that you have an IQ score above 90 is 0.7475, or about 74.75%. Okay, now these numbers are rounded to 4 decimals. I did not get exactly 0.7475. I rounded it to 4 decimals, so those rules do still apply. All right, and then last one. Find the probability of having an IQ between 90 and 120. And now I wish I had given myself a little bit more room. But to do our 3 steps, the first step, calculating our z-score, we're going to have to do that for 2 different values. So our z-scores, we're going to have to do, oops, not an x, a z1 for 90. Which good thing is we've already done that one, negative 0.6667. And then we're going to have to calculate a second z-score for the second value. So z2, 120 minus 100 over 15, which we've also done this one already. I'm so sneaky. Okay, so I always give the smaller value the z1 and the larger value the z2, just because 1 is smaller than 2. You could also do za and zb if having more numbers involved is confusing. Okay, so step 1, calculate the 2 z-scores. Step 2 and 3, draw your curve, label everything, so 0, negative 0.6667, positive 1.3333, and then step 3, shade what we're interested in. We're interested in between. And now, step 4, normal CDF. We want it to start calculating probability at 0.6667. We want to stop calculating probability at 1.3333, 0, 1, and our answer is 0.6563. Okay, so that is how you calculate probability when given a real-world example or a real-world application. So again, we're still looking for those keywords: below, less than, above, greater than, in between, and using the same sort of ideas that we used for these problems up here, but now we've just applied it. And because we've applied it, we can interpret these probabilities, which I kind of was doing as we were going along. So I'm going to write out a formal interpretation for this last problem that we did, finding the probability of having an IQ between 90 and 120. So an interpretation, there's actually two of them. I've done a lot of black. I haven't done a lot of blue. Okay, so one interpretation is that 65.63% of people have an IQ between 90 and 120. The second interpretation, let's do that in, sure, let's do red. I don't use a lot of red. The second interpretation is that if we randomly select an individual there is a 65.63% probability or chance of that person having an IQ between 90 and 120. So this is seeing the interpretations again, first as a group interpretation and then as the individual interpretation, which we talked about back in Module 8, how you can have a group or a individual interpretation of a probability. Okay, so this is what you're going to need to do whenever you have a question that says to find a probability and you've been told that you're looking at something that's normally distributed. Okay. So now the other thing that we can do is if we've been given a probability, we can find the X value that goes along with that. Or in this case, we were looking at IQ scores. So if I tell you that 25% of people have an IQ score below some number, what is that number? So we can work backwards to find that value. So there are again 4 steps to this. The first step is to draw the curve. The second step is to shade the approximate area, again less than, greater than, or in between depending on the problem. The third step is to use technology to find the z-score that goes along with that area. And then the last step is to solve for x. So it's basically like, if I come back up here, if I said that I know that 90.88% of people have an IQ score below some number, what's the IQ score that kind of goes along with that? Okay, my answer would be 120, or something very close to 120 because we did have to round. So we're going to come down, we're going to look at an example. Now this first example is worded wrong. And I apologize. This should say find the IQ score so that the area to the left is 0.7019. I was copying and pasting when I put these notes together and I just missed that one. So find the IQ score so that the area to the left of that is 0.7019. So first step is to draw and shade our curve. First two steps actually. So I'm going to keep the same color, so I'm going to draw my curve. Okay, and I'm going to shade 0.7019 starting from the left. So I'm going to start on the left and I'm going to start shading. And I'm going to shade until I've shaded about 70% of my curve. Now one of the things with this curve is our mean of 0. If I go and I label that real quick, that cuts our graph in half. So that means 50% of the data is below the middle of 0. So I know I need to shade at least half. And then I need to go a little bit further than that. Maybe to about right there. That's where I'm going to stop. So this is an unknown z-score. I don't know what that z-score is. I need to figure it out. Okay. So now we're going to use technology to find that z-score. So the z-score is going to be found using inverse norm, which works backwards for us. An inverse norm only asks for three things. It asks for the area to the left of the unknown z-score. I'm going to say that one more time because that's very important. The first thing it wants is the area to the left of your unknown z-score. So in this case, we were given the area to the left, so that's 0.7019. And then it wants the mean and the standard deviation for your curve. So again, our mean is 0 and our standard deviation is 1 because we want the z-score. So when we do that, we get a value, which I have to find what it was again, 0.5299. So 0.5299 is how many standard deviations above the mean we are if the area to the left of us is 0.7019. So I have one more thing I need to do. I'm actually going to do it in blue. Is I need to go and find what that x value is. So remember back in Unit 1, I gave you an equation. X equals your z-score times your standard deviation plus the mean. So we can use that equation again to solve here. So in this case, x equals our z-score is what our calculator gave us, 0.5299, times our standard deviation is 15 plus 100. And we get 107.9485. So if you have an IQ score of 107.9485, then the probability of someone having a z-score less than you is 0.7019. So that's what we did in this problem. We were given the probability of someone having an IQ score less than us, and then we went out and we found what our IQ score would be then. So let's go ahead and look at another example of this. So find the IQ score that is in the 75th percentile. So we talked very briefly about percentiles back in Unit 1. And if you recall, the key thing with a percentile is that it is the probability, or it is the percent less than or equal to you. Or the percent less than you. It actually does not matter with the normal whether it's less than or equal. Okay, so it's the percent less than you. So the 75th percentile means we're looking for 75% of the people have an IQ score less than what number? So I'm going to follow the same 4 steps that I just did. So steps 1 and 2, I'm going to draw my curve. Okay, and I'm going to shade 75% of it, which again, I know I have to go past the middle because the middle is only about 50%. Well, the middle is only 50%, not about. Okay, again, it's not an exact science as to how far you need to be shading this, just so long as, you're not shading the whole thing when I am only asking for 75%, or you're shading more than half because we want 75%. So now that we've shaded this, we have an unknown z-score here that we need to go and find. So to find that unknown z-score, we're going to use inverse norm, step 3. We're going to put in the probability to the left. So the probability to the left, so the probability of this, which is 75% or 0.75, it's always going to want it as a decimal. If you put in 75, you're going to get an error message. Okay. And then 0 and 1. And when you do that, you get 0.6745. So now we have the z-score, so that 75% of the data is less than our z-score. So the last thing we need to do is solve for x. So x equals 0.6745 times 15 plus 100. X, or the IQ score, is equal to 110.1175. So that's an example of 2 different problems that are asking for a less than. Okay, or they've given you the less than probability, and they're asking you to find the IQ score. So now we're going to look at another one. Find the IQ score that has an area to the right equal to 0.3214. So now this is the opposite of what we just did. So step 1 and 2, draw and shade your curve. So I'm going to draw my curve. And now I want the area to the right equal to 0.3214. So I'm going to start at the right and I'm going to shade through 32.14% of my curve. So I know that in the middle, that cuts it into 50%. So I don't want to go that far. Okay, so I'm going to go to about here. Again, not an exact science, maybe a little bit further. Okay, I'm just shading. So the area of what I just shaded is equal to 0.3214. Now remember I said, and I emphasize this, inverse norm, the first thing it wants is the area to the left of your unknown z-score, which is this guy right here. Our z is a question mark. Well, I have the area to the right of my unknown z-score. So I need to figure out what's the area to the left. What's this area that I'm shading in light blue? So I'm going to find that by using the complement rule, and I'm going to do 1 minus 0.3214. And I didn't write this number down, which gives me 0.6786. Because all probabilities have to sum to 1, So if I know that 0.3214 is above my unknown z-score, then 0.6786 must be below, because combined, the whole area underneath this curve, because it's looking at probability, has to equal 1. Probability always sums to 1. So now I can go to my inverse norm and I can put in 0.678601, and I get 0.4637. Okay. So your 0.4637 standard deviations above the mean. And your z-score, nope, that is your z-score. Your IQ score, 15 plus 100, x equals 106.9555. So if you have an IQ score of 106.9555, then 32.14% of people have an IQ score greater than you. Or 32.14% of people have an IQ score greater than 106.9555. Or the probability that we randomly select someone with an IQ score of 106.9555 or more is 32.14%. Okay, so this one had the added step of having to use the complement rule before we could do step 3, because inverse norm wants the probability to the left, or the probability less than, the unknown z-score. I cannot say that enough. Alright, the last one we're going to do is find the middle 50% of IQ scores. So this one's a little bit trickier. So we're going to start with our curve. I'm going to change colors now. I'm kind of sick of purple. So we're going to do steps 1 and 2. We're going to draw our curve. I'm going to draw it pretty big, actually. Alright, so there's my curve. It's not a very good curve, but I'm just going to